In this exercise we are going to do spatial planning using Map Algebra. The Department of Planning of the imaginary oasis in QGIS is planning to build a National Institute for Oasis Management in their village. They came up with the following conditions for building the complex. First, no industry, mine or landfill within 300 meters of the new complex. Second, not on locations presently in use for buildings, water or roads. Third, the slope should be less than or equal to 3%. Fourth, the distance from an existing road should be less than 500 meters. Fifth, the area should be contiguous. And finally, the area should be greater than or equal to 2 hectares. You can find the data for this exercise on our OpenCourseware website, ocw.un-ihg.org. If we scroll down, we will find the data of exercise 4. You can open the zip file and extract it to the exercise folder. Let's go to QGIS and first make a favorites of this folder in the browser panel. So now we see all the GIS layers that are available in that folder. If we click right, we can choose properties and read the metadata, such as the projection. We see that it's UTM Zone 30 North, WGS 84. We see that it has 60 by 60 pixels and a minimum of 0 and a maximum of 5. We can do the same for the vector layer. We see it's in the same projection. We see it has an attribute dn. So let's add all these layers to the map canvas. We click right and we say add layers to map canvas. And let's reorganize it a bit so the area mask is not covering the layers. When we hover on the name of the layer, we see the projection, the EPSG code. If I click right, properties, we can style this. Because this is discrete data, we can use paletted or unique values and use each unique number in the raster as a class value. And we can label the classes. So 0 means no buildings. 1 means house. 2 is public building. 3 is landfill. 4 is industry. And 5 is mine. You can also here change the colors to something more intuitive. And then we can click OK and we see the result. So the first step in the criteria is to define where the industry is, because we need to find a certain distance from the industry pixels. We can do that using the processing toolbox. In the processing toolbox, we go to the Saga tools, and under Raster tools, we find Reclassify Values Simple. With this tool, we can use a so-called lookup table to recode values in the raster. In QGIS 3, we can only save it at this moment to SDOT files, which is similar to GeoTIFF. It's a format from Saga. We choose the table and we add a few more rows and make sure that for the low value, the values of the classes are given. We keep high value as it is because we only look at the low value for changing, and we don't use ranges in this case. So we now reclassify 0, 1 and 2 to 0 and 3, 4, 5 to 1, because classes 3, 4, 5 we consider as industry. This is the result. It's a Boolean map. And we change the colors. So 0 is false, we make it red. And 1 is true, we make it green. Where 0 means that we have no industry. And 1 means that we have industry. We can check the result, always verify what you calculated. We activated build G and we visualize the green parts in this case in our new Boolean map, and we see indeed that the identify tool gives the right results. It's also good practice to rename, so we can use this label in other tools. The next step is to calculate the distances, the so-called Euclidean distance. And we want the distance in georeferenced coordinates. Here you see that we use the zeros as the pixels that the distance is assigned to, so the distance to the non-zero pixels. We save it in this case to a geotiff with the name int_dist, and it uses the GDAL proximity batch file. And we click run in background and we close this dialog. It's executed. And let's change the styling. Go to single band pseudocolor. It's a continuous map, and we would like it to go from red, close to the industry is bad, to green, further is better. And we remove the stops in between, we only need 2 colors. So it goes from red to green. There we are. Because it's continuous, it will make a continuous scale. And there we are. Now the next step is to use the distance threshold that is in the requirements of this exercise. We rename the layer. So we use the Raster calculator. We double click on int_dist and we set it to the criteria larger or equal to 300 meters. And we call the output noint.tiff. Click save. When we click OK, this is performed. It creates another Boolean map where 0 is industry and 1 is no industry at the distance of 300 meters. We can copy the legend from the other Boolean map and paste it to noint. You see how easy that works. So that was the first criteria. It should be further than 300 meters from industry. The second criteria says it should not be on existing buildings. So we say buildings map equals 0. That means that where are no buildings is true, where it's 0. And where there are buildings, it will be false. So we save this as no build. We can again paste the legend. And with F7 we get this layer styling panel, so we can quickly change the labels. So red is with buildings and green is no buildings. In the second criteria there was also that we are not allowed to build on pixels with water. So there's this map is water. When it equals 0, means there's no water, so we should make that true. And then for all the pixels that have water, we should make that false. We call this map nowater.tif. There we go. We can again paste the legend of this Boolean map. And we change the label. You see the layer styling panels automatically updated with the selected layer. So red has water and green has no water. And the third one in this second criteria is that we are not allowed to build on existing roads. So there's a map is road. If it equals 0, means that no roads gets true. And where there are roads, it gets false. So with all these criteria, we want to end up with all the areas that are true, given the criteria where we can build. So again, here we paste the legend, and in the layer styling panel, we change the labels to 0 is roads and 1 is no road. The third criteria is about the slope, which should be less than 3%. So we have this topo map. So let's style it using single band pseudocolor. We can change the colors to a preset for elevation. So we choose the CPT City catalog, and there we choose topography and we choose elevation. And we see now automatically our map is updated with nice colors for elevation. Now we want to calculate the slope. Raster analysis slope. And we want it in percentage, so we check the box and we want to compute the edges. And we save the output to slopemap.tif. And there's our slope map. Also here we should give some intuitive colors, so we choose single band pseudocolor. And it would be good to have a ramp that goes from green to red, for example. Where green means a low slope and red means a very steep slope. We can remove the stops. And there it is. Now we see in red the steep slopes. Rename it to slope map. And now again we need to have the threshold there, so the slope map should be less or equal to 3%. We call this one no steep.tif. You can paste the style again. It's again a Boolean one. And there we are. And we can change the labels in the layer styling panel. Steep for 0, no steep for 1. And we can again verify using the identify tool. And we see that it is indeed what we wanted. The next criteria is that we should be close to a road. In the roads map, let's style it first. It has 3 classes. Class 0 is no road. Class 1 is a dirt road. And class 2 is a tarmac road. And we are only interested in the tarmac road. Let's give it some intuitive colors. Brown for the dirt road, and black for the tarmac road. So we can say that roads map equals 2. So it's only true for the tarmac roads. And dirt roads or no roads gives false. We call it tarmac road.tif. There we are. We can paste again the style. And we can change the label. Zero is no tarmac and 1 is tarmac. Now we need to calculate the distance again, so we go to the proximity function and we want again the georeferenced coordinates. We want from all the zeros to the non-zeros, so that's okay with the defaults. And we save it to the file. And we call it tardist. We style it. And here it would be also good to have green for close to the road and red for far from the road. And we remove the different stops. There we go. The greener the better. We also need to rename the map. We call it tardist. So in a raster calculator we can then threshold tardist less than 500. So it will be true less than 500 meters from tarmac and false further than 500, and we call it tarzan.tif. Again we get a Boolean map. We paste the style. And there it is in red where we are very far from the tarmac. And in green where we are within the 500 meters from tarmac. Now we can combine all these criteria. So everywhere where all these things are true, no build and no industry and no road and no steep and no water and within the tarmac distance, if they are all 1, then we save it to neomgo.tif. And this is the result. It's a Boolean map where the first criteria are met on the pixels that get a value 1. And the others get a value 0 and are false. Next we want the clusters to be contiguous, but our zeros are also one big cluster, so let's remove the zeros and we use this clip raster by extend. And we use the extend of the same file, so neomgo, and we assign 0 as no data, so all the zeros will become no data. That's what we want, all the red areas. And then we save it as isneomgo.tif. So GDAL is performed, the GDAL translate. We run it in the background. And there it is. We rename it to isneomgo. And we also paste the style because it is Boolean, but zeros are no data, so if we hide all the layers and we only show this one, then we only see the values 1 and the zeros are transparent. Now we use the Clump function to give unique values to each cluster. We save it to NeomGo Cla, and we also give that as the title, and then we perform it, and then we close the dialog, and we see that all the pixels that are horizontally and vertically connected are a unique cluster, and diagonal connections are not causing them to be one group. So we rename the layer to NeomGo Clue. So now we want to convert it to polygons in order to be able to calculate the areas of each polygon. So we name the field of the output in the polygon Clump, and we save it to a shapefile. Call it NeomPoly. And there we run it. We rename it to NeomPoly. And we choose in the styling that it's categorized using Clump. There we classify it, and each cluster gets its own color like in the raster. Here's the attribute table with the unique numbers. And we select by expression all the areas that are larger than 2 hectares, which is 20,000 square meters. And there we are, and there are 5 areas selected. They are presented here in yellow. We can export this to our final layer. Selected locations layer. Let's remove the other ones. And there we are. These are the numbers of the layers, and we can also calculate their areas. We add a column. It's a decimal number. Since it is in meters, we make it a bit bigger, like 10 units with 2 decimals. And we choose here area equals and we choose again area from geometry. Remove Clump. And the preview looks okay. So area equals $area, we update, and there are the different areas in square meters. We save the layer. And we can put Google Satellite in the background to see where it's located in the desert. And with this analysis, we have demonstrated that we can use the multiple criteria with Map Algebra to select the sites to build the National Institute of Oasis Management.